All right, so there is one thing that we have to keep in mind with the first derivative test, and that really comes down to earlier in the year. If we have a graph that's x to the fourth power, right, a general generic look of a graph that's x to the fourth power might be something like this. We might have kind of that W shape, but it doesn't have to be, right, more of this W shape. What it could look like more is still maybe kind of like a flattened parabola, right? So maybe something like this. Where we see it kind of flatten out a little bit more, but it still has that parabolic look. And what's happening here is if we have a degreed polynomial that's to the fourth power, we might expect to see 3 extrema, right, maxes and mins, but we might not. We might only see 1 or really any number less than, it doesn't have to be that 3. So the way we look for that with the derivative graph is still by looking at the tables and looking at the number lines of our first derivatives and seeing their trend to see if they're going positive to negative or negative to positive. So yesterday you guys saw these top graphs where it said negative to positive, positive to negative. That created our maximums and our minimums. But really, that's not always the case. Sometimes we might see a graph, in this case, it's an increasing graph. Whoops, sorry about that, guys. It's an increasing graph, and then it stops. And it stops at this point C, that critical value, and instead of turning, it decides, no, you know what, we're going to keep going, and that graph continues. And we might see the same thing in the opposite direction. We might see a graph decreasing, take a quick break, stops at that critical value C, but then it continues down. And when this happens, there is no maximum, there is no minimum, so we don't want to get tricked into thinking that all critical points are going to create maximums and minimums. It doesn't have to be that way. So the question is, how do we handle that? How do we find it? And how do we look for it? So let's take a look at a quick example here. What we're going to do is find all relative extrema, maximums or minimums of this following function. We have f of x is equal to x to the fourth minus x cubed. Now, same thing as yesterday. What we want to do is find the derivative. So we're going to find f prime of x. In this case, it's 4x cubed minus 3x squared. And then we want to set it equal to 0. We want to solve for those critical points. So we're going to have 0 equals x squared. Factor out that x squared, and then you have 4x minus 3 on the inside. So we're really going to get 2 critical values here. We're going to get x is equal to 0. When we take the square root of that x squared, we're just going to get 0. And then on the inside here, we're going to have x is equal to 3/4. So just like with our other graphs, what we're going to do is we're going to take a look at the number line. So we'll create a number line. Whoops. We'll create a number line. We'll plot these points on that number line. So we're going to put one critical value right here at 0. And another critical value at 3/4. So we're going to have to kind of space out a little bit here. Now, we still need to pick those test values. We need to pick a test value that's to the left of 0. So I'm going to pick, let's scale this a little bit more. I'm going to pick -1. We need to pick a number that's in between 0 and 3/4. So I'm going to pick right in the middle, 1/2. We need to pick a number that's past 3/4. So I'm going to pick 1, right? It's a number further than 3/4. Now, we still need to find out, is it positive or negative at those test points? So we're going to go and substitute these values into our derivative. Make sure you're substituting into the derivative. So again, I put my f prime of x into my y equals screen. And then I took a look at my table. Now, I changed my table on my calculator to match the fact that I need to have a 1/2 here. So I changed my table set, my delta table, to being 1/2, so I could still get the 1 and the -1 in my test points as well. So when I look at my table for f prime at -1, my derivative value is -7. So I have a negative sloped graph here, right? That means we are decreasing up until we hit 0. Then at 0, the graph stops, right? The slope stops for a moment, and we need to see what's going on in between 0 and 3/4. So when we substitute 1/2 in, f prime at 1/2 is -0.25 or -1/4. Now a -1/4 is still a negative slope, so it is still decreasing. So we can't connect that curve there. It's decreasing slope, it stops, and then it continues to decrease. That's not a maximum or a minimum. Now we still have one more test point to do, so we're going to test f prime at 1. And f prime at 1 is 1, right? It's a positive value. It's a positive value, which means it's an increasing slope. And that is where we found our first relative extreme. Right? So in this case, we found a minimum. We have a decreasing function that stops and turns increasing. So at this point, at that point 3/4, we found that we have a minimum at 3/4. So we need to do, just like yesterday, is find, okay, what's the y value that goes along with it? So we need to substitute that 3/4 into our f of x, right, the original function. I'm going to keep my answer in a fraction form. So I have f of 3/4 is equal to negative 27 over 256. Which means I have a minimum at the coordinate point 3/4, comma, negative 27 over 256. So what we want to be careful with the first derivative test is if you see a decreasing slope, critical point, decreasing slope, we don't want to be tricked into thinking that we have a minimum or maximum at that point. We have to see the signs change. We have to see it go decreasing to increasing or increasing to decreasing in order for us to have a